Hi, welcome back to another GCSE Maths past paper walkthrough. Today we'll be looking at AQA 2022 paper 2. It's a calculator paper, so make sure you've got your calculator to hand. My name's Jonathan. I'm a Cambridge Maths graduate and a Spires tutor. Let's get into it. So, question 1. Circle the fraction that is equal to 1.25%. This is a calculator paper, so we're not going to overcomplicate this. We're going to find our calculator. We're going to type literally 1.25 and then find the button that says percent. We're going to type that in like that. Then we're going to hit, oh, come on, focus. Type it in like that, hit equals, and it tells us it's 1 over 80. That's all we need to do. It's 1 over 80, and we can move on. Just quickly, if you want to know why it's that, percent, the symbol comes from the Latin out of 100, which is the same as dividing by 100. So if you don't have a percent button on your calculator, you can do 1.25 and you can do divided by 100. And that should give you a fraction. If it doesn't give you a fraction, you probably have one of these buttons somewhere on your calculator that lets you turn from a fraction to a decimal. So that's all we need to do for question 1. It's 1 mark, nothing more. Question 2. Circle the expression that means the probability of A and not B. So there's a couple of things we need to know about set notation. So set notation is what we use to refer to these like U's and N's and apostrophes and stuff. So the P just means probability of, and then whatever's in the brackets. And then when we have the apostrophe means not. The U is for union, which we can call and. Which we can call or. And the N is for intersection, which we can call and. I'm just going to try and make my T look a little bit more like a T. So we've got not, or, and. The reason for this is because when you have a Venn diagram, it's a very skinny Venn diagram. When you have a Venn diagram, two circles overlapping, we're talking about two sets or two sets of events that could happen at the same time. The U, the union, is everything in both circles. So it could be A, it could be B, it could be both. So we're talking about A or B. I don't mind if it's one or the other or both. It's A or B. That's the union. That's the U shape. But the N for intersection, N for intersection, I like to say because it helps me remember. The N is for the and, or N for and, if that helps you. It's for the bit that's in both. So it doesn't need to be just A or B. It has to be A and B. So the intersection is the bit between the two. So what we're being asked for is the probability of A and not B. So we've got A and not B. That's what the B after B apostrophe, that's not B. So that's our answer, and we're happy to move on. Just to show you, if this is A and this is B, and that was the rest of our space, we're looking at the intersection of this circle with everything that isn't in this circle. So we're looking at the intersection of this and this going around B. But the only things that are in both of those are this bit. So that's what we're being asked for, A and not B. Okay, moving on. Oh, I've turned a page. Okay, question 3. We're being asked to circle the triangular number. What is a triangular number? Triangular numbers are numbers you can draw as triangles. So I'll show you the first couple. 1, well, that's maybe not super helpful, super obvious as a triangle, but it's a little triangle like that. And then 1 plus 2 is 3. So there's your triangle. Or 1 plus 2 plus 3 makes 6. That's another triangle. 1 plus 2 plus 3 plus 4. It's another triangle. That's 10. So 10 is your fourth triangular number. What's our next triangular number? Well, you might be able to spot the pattern. We've done 1, We've done 1 plus 2. We've done 1 plus 2 plus 3. 1 plus 2 plus 3 plus 4. So we got 1, 3, 6, 10. The next one's going to be 1 plus 2 plus 3 plus 4 plus 5, or 15. And that is the only triangular number there because, as you saw, 9 and 12, we didn't hit when we were going up, 1, 3, 6, 10, 15. And the next one, if we were to keep going, 1 plus 2 plus 3 plus 4 plus 5 plus 6, we'd actually get 21, which is bigger than 18. So we know 18 isn't one of them either. And just to show you, we can draw 15 circles like that and make a little triangle. So there it is. That's question 3. Moving on to question 4 then. Circle the inequality represented by the diagram. So inequalities are where you have less than or more than symbols. And in this case, we've got something at -5 and something at 1. And thankfully, all of our answers have something at -5 and -1. So we know that we've got an x. They're connected by this line in between. We're looking for an x, which is just a placeholder for a number we don't know. We're looking for a number between -5 and 1. So x is between -5 and 1. But now this is the bit that they're actually asking us. What do the filled in and not filled in circles mean? When the circle is filled in, that means you include 1. X could be 1. When it's not filled in, we're excluding -5. So x can't be -5, but it could be 1. Now, this is a strict inequality on -5. It can't be equal to -5, but it's also strict inequality on 1. So it can't be 1 either. So that's not right. And in fact, this lets it be equal to -5 and doesn't let it be equal to 1. So that's not right. So no, no. This one lets it to be equal to, actually, this says 5, not -5. So that's definitely wrong. This is our answer because we've got the strict inequality where we're not including -5. And we've got the or equal to, less than or equal to sign, where we are including 1. That's it. So, next question. Question 5. Solve 5 brackets 2x minus 1 is equal to 6x plus 9. What does it mean when a question like this asks us to solve? We're being told find x. So whenever you see the word solve, it just means find the unknown. In this case, it's x. X is a number. We want to know what that number is. Great. So when you see two things next to each other, it often means multiply. So here we've got 5 and then a bracket. That means 5 times the bracket. Or here we've got 2 times x. Or 6 times x. You know, that's what those mean. How do we solve this? Well, there's a couple different ways to it. I think the easiest way is probably to start by expanding the brackets on the left. So because we've got a 5 times everything in the set of brackets, we can do 5 times the first thing in the set of brackets, and then 5 times the second thing in the set of brackets, and write that down. So 5 times 2x is 10x. 5 times -1 is -5. Don't forget that minus sign. There is -1, so it has to be -5. Then on the right-hand side, we're just going to copy it exactly as it was. We're not going to change anything. The whole aim with these questions is to make sure that the statement they give you with an equality sign, with an equals sign, that you don't do anything that makes that no longer true. So when I expanded the bracket here, I'm not changing the total amount on the left-hand side. So I don't need to do anything to the right-hand side. It's already expanded. I don't need to do anything to it. I'm keeping them equal. I'm not changing them. But on my next move, what I'm going to decide to do is say, actually, I want all my x's on the same side. I don't like having 10x on the left and 6x on the right. So I want all my x's on the same side, which means I need to get rid of the 6x on this side. So I'm going to take away 6x from this side. And that's going to leave me just with 9. But if I do something to the right-hand side to keep the two sides equal, I need to do the same thing to the left-hand side. I need to also take away 6x from the left-hand side. And 10x minus 6x, if you have 10 of a thing and you take away 6 of that thing, you'll end up with 4 of it. So I'm going to get 4x. And then I've not done anything to this minus 5, so that still has to be there. So I've just taken away 6x from both sides, and the units, the numbers without x in them, have stayed the same. But now I'm looking at this and I'm going, well, why have I got units on both sides? Why don't I get all of those on the opposite side from the x? So I'm going to do that. I want to get rid of this minus 5. It's too complicated. I want x on its own, so I'm going to get rid of the minus 5. Well, to do that, I'm going to have to add 5. And that's going to leave me with 4x. But to keep this equal, I'm going to have to do the same thing to the right-hand side. I'm going to have to add 5. 9 plus 5 is 14. Finally, to get x on its own here, I've got something times x. I've got x times 4. Well, to undo the times by 4, I'm going to divide by 4. And then I'll end up with x on its own. But if I've divided the left-hand side by 4, I'm going to have to do the same thing to the right-hand side. So I'm going to get 14 divided by 4. How do we work out 14 divided by 4? Well, let's remember this is a calculator paper. We can put it into our calculator and it will simplify it for us. Alternatively, 14 and 4 are both even numbers, so we can divide the top and the bottom by 2. We're going to get 7 over 2. And that will be our answer, 7 over 2. Alternatively, you can write 3.5. Equally valid, equally correct. You can write 3.5, that's fine. In fact, just because it's a calculator paper, I'll choose to write 3.5, but 7 over 2 is just as valid, just as correct. You'll get all the same marks. Last thing to do, just before we move on, we have answered the question, but we should always check our working as we go. So let's check our working as we go. We're going to substitute this answer into the original equation and see what we get. Do the two sides end up equal? So for our check, the left-hand side tells us 5 times 2 times 3.5 minus 1. So when I'm substituting, I'm replacing the x with the number that we now know x to be. So that's what the left-hand side says. To sort of unravel that, we're going to do inside the brackets first, which means we're going to do the multiplication inside the brackets first. 2 times 3.5 is 7. 7 minus 1 is 6. So it's 6 times 5, which is 30. Or type all of that into your calculator and see that it comes out as 30. So the left-hand side is 30. Let's check. Is the right-hand side also 30? If it is, that means we've got the right answer. The right-hand side says 6 times x, so 6 times 3.5, that's our x, plus 9. Well, if you type that into your calculator, you're going to find that it is in fact also 30. And we know that the left-hand side is equal to the right-hand side, so we found the right x. Now we can move on. Question 6. So we're being asked to show that 2,125 can be written as a cube number multiplied by a prime number between 10 and 20. So that's a lot. We need to figure out first what cube number we might need, and then what prime numbers are there between 10 and 20. Well, actually, let's start there because there aren't many prime numbers between 10 and 20. So if we're looking for a prime number between 10 and 20, our options are 11, 13, 17, and 19. Why is it that those are our only prime numbers? Well, what is a prime number? A prime number is a number that can be divided only by 1 in itself. It has no smaller numbers that divide it into whole numbers. So if we take 15 as an example, 15 can be written as 3 times 5. And that means that it's not prime because we can write it as a multiplication of smaller numbers. We can't do that with 11 or 13 or 17 or 19. We could do it with 18, though. That's why that's not on that list, because 18 is 3 times 6. So that's why these are prime numbers. That's why these are our only prime numbers. You can check the rest of them for yourself. So there's only 4 numbers we can choose from. And they need to multiply by some cube number to get 2,125? So what do we know about 2,125? Well, firstly, we know it ends in a 5. So it's a multiple of 5. In fact, I think I can do you one better and say because it ends in 25, it's probably a multiple of 25. In fact, it is. It's a multiple of 25 because it ends in 25. So if it's divisible by 5 and it's divisible by 25, and we're looking for a cube number, it sort of makes sense to check, is there any chance it's divisible by 125, which is 5 cubed? Well, let's find that out. Let's find out what is 2,125 divided by 125. And again, this is a calculator paper. So you can type it into your calculator. I'll do it now. 2,125 divided by 125. And I see that the answer is 17. Can't really see my calculator, but I can see that the answer is 17. And 17 is in fact one of our prime numbers. So we know, so to show that it's a cube number multiplied by a prime number between 10 and 20, we have to write 2,125 equals 5 cubed to show that we know 125 is a cube number times 17. And that then is showing what we need to show. And we're done. That's all we need to do. If it wasn't obvious, or if it wasn't somewhere that you could get to be like, oh, 5 cubed is 125, and this looks like it might be divisible by 125. If that's not the kind of step you think you can make, we can sort of do different methods here. And in fact, probably the most straightforward method is the prime factor tree. Seeing as we're looking for prime numbers anyway, you know, between 10 and 20, we can start with our number 2,125. And we can definitely all see that it's divisible by 5 because it ends in a 5. So let's divide it by 5. That's prime, so we'll circle it. And what do we get when we divide it by 5? We get 425. Well, we know that's divisible by 5 again because it ends in a 5. So we'll do that and we'll circle it. What does our calculator say? It says we're left with 85 when we divide by 5. Same trick again. We know it's divisible by 5. So let's divide it by 5. And what do we get? We get 17, which we know is prime. So that's the most straightforward way of solving this. We just do the prime factor tree, and we see that it is, that we can write this as 5 times 5 times 5 times 17, which is 5 cubed times 17, which is all the question wanted. Cool. Question 7. Sam types a constant number of words per minute. He takes 8 minutes to type a report of 416 words. How long does it take him to type an essay of 1,534 words? Give your answer in minutes and seconds. So let's start by trying to understand some of the words we've just been told. There's a lot of words. Whenever I see words in maths problems, I go, oh no, it's too many words. So let's try and break it down. Let's try and understand. What does the first sentence say? Sam types a constant number of words per minute. Okay, whatever rate we're dealing with, the rate is constant. So we can deal with it as we normally would. We don't need to worry. Second sentence, he takes 8 minutes to type a report of 416 words. Well, we can work out his total number of words per minute from that. So if it's 8 minutes for 416 words, then 416 divided by 8 will give us his words per minute. And I'm going to use my calculator. I'm going to do 416 divided by 8, and I get 52. So he does 52 words per minute. I'm going to use WPM for words per minute. Okay, so that's the second sentence. Now let's see what the third sentence is saying. It's saying, how long does it take him to type an essay of 1,534 words? So we've got his rate of typing. We know that his rate of typing is constant, and we want to know how long, with that constant rate, will it take to write 1,534 words? Well, we can think of this like a speed, right? We worked this out by doing the total number of words divided by the total number of minutes. And in fact, that's what WPM means, words per minute, words divided by minutes. So if we want to find out the number of minutes, we can do W, the total number of words, divided by words per minute, and that will give us the total number of minutes. If that's not clear, that's okay. It's very similar to what you do when you do speeds. So maybe you've seen it in a triangle, and you've drawn this kind of thing, and you've said, okay, speed is distance over time. So you've got speed is distance over time. So in my triangle, I can cover part of it, and whatever I cover, I see the rest. So if I'm looking for distance, I can cover distance, and I see that distance is speed times time. If I'm looking for speed, I can cover speed, and I see that speed is distance divided by time. Or if I'm looking for time, I cover time, and I see that the time is the distance divided by the speed. Well, we've got the same thing going on here. We've got the words per minute, and the minutes. So if we want to find out the minutes, we'll cover the minutes, and we'll see that it's words divided by words per minute. So total number of words we're looking for is 1534, divided by the speed that he's writing at, which is 52. Type that into our calculator, and what do we get? 29.5. And now we're asked to give it in minutes and seconds. We've worked this out in minutes. So what's 29.5 minutes in minutes and seconds? Well, it's 29 minutes and 30 seconds. Moving on. Question 8. So, a school play takes place each day from Monday to Friday. Here are the attendances on 4 of the days. For all 5 days, the mean attendance is 90. Work out the attendance on Friday. So I'm going to extend the table here. I'm going to say we care about all of the days, including Friday. We just don't know how many people went on Friday. So let's put a placeholder in. Let's use X as a placeholder. Let's say X many people went on Friday. What does it mean to work out the mean? So the mean is when you add everything up and divide by the total number of things. So the mean attendance then would be the attendance on all of the different days added together, including Friday, divided by the total number of days, 5 total days. And now we want to, and we know that this is 90 because it tells us the mean is 90. And now we want to undo this equation to find X on its own. In other words, we're solving for X. So let's start by undoing the fraction, right? I've got a lot of numbers being added together and then divided by 5. So let's undo that dividing by 5. We're going to multiply by 5 to undo the fraction. Need to do the same thing to the right-hand side to keep the equation equal. So we're going to get 72 plus 83 plus 88 plus 97 plus X equals 90 times 5, or 450. Then what we're going to do is we're going to add up all those numbers on the left-hand side, because there's a lot of them. So 72 plus 83 plus 88 plus 97. You're going to get 340. And now all we need to do is get X on its own. So we need to get rid of the 340 by subtracting it from the left-hand side, which means we're going to have to do the same to the right-hand side. We get X on the left. That's a really unneat X. And then on the right, we're going to get 110. And that will be our final answer. The attendance is 110. So we can write that here. That's That's all there is to it. So, question 9. Rosie makes phone calls to try to sell broadband. Today she made 120 calls. The table shows the results. So we've got one column that's result of call, one column that's frequency. And you can see we've got 3 different categories. We've got a not answered call, an answered but sale not made, and an answered and sale made. And we've got different numbers of each of them. We're being told to work out the relative frequency that a call was not answered. So what is relative frequency? Relative frequency is the frequency relative to the total. So the frequency of not answered here is 33, and the total calls is 120. So how do we relate them? We're going to ratio, we're going to use fractions. So 33 divided by 120, which you could also work out as a decimal, 0.275. Either answer is correct. It's 1 mark, don't need to overthink it. Relative frequency is the frequency divided by the total. So in the rest of the week, Rosie will make, we're on to part B now. In the rest of the week, Rosie will make 500 calls. Using the results in the table, how many sales does she expect to make during the rest of the week? So now we're talking about the expected value. The expected value comes from taking the relative frequency and using it to guess, to estimate. We don't like guess, we use estimate. To estimate, or to guess, how many people she will make sales with. So in the rest of the week, she's making 500 calls. The relative frequency, let's work that out first. The relative frequency of sales per call is something we can work out from the initial table. So we're looking at this out of 120. So 6 out of 120 is our relative frequency of sales made per call made. So then we're going to have to do that relative frequency. We're going to have to multiply it by the total number of calls we're expecting her to make for the rest of the week. We just type that into our calculator, we get 25, and that's our answer. So the expected value is the relative frequency times the total. That's all. And that's the end of that question. We can write 25 in our answer box, and we can move on. Question 10. So, Harry and Ellie each bought a printer and a hard drive. Here is some information about how much they paid. So we've got a two-way table here. We've got Harry and Ellie on the left. We've got printer and hard drive on the right. And we can see that for Harry, we've got nice and easy to read numbers. But for Ellie, the people setting the question have decided to give us percentages. So we're told that Ellie bought the printer for 10% less than Harry, and she bought the hard drive for 20% more than Harry. So Ellie says, in total, I paid more than Harry because 20% is greater than 10%. But is she correct? And I'll leave you to think about that for a moment while I have a drink of water, and then I'll explain. Is she correct? Well, we don't know. We're going to have to do a little bit of calculating. So how much did she spend on the printer? Well, Harry spent 80 quid and she spent 10% less than Harry. So we're going to take the 80 quid and we're going to subtract 10% of 80. And that's going to be how much she paid. Now, whenever you see something like this, 10% of 80, you could replace that of with a multiply symbol. It will always work. So 10% times 80. And if we just type that into our calculator, if we literally type 80 minus 10% symbol times 80, we will get the right answer. We'll get 72, which is correct. There is a slightly better way. If you're taking 10% less, then when you had 100% and you're taking 10% off, you're now on to 90%. So instead, we can work out 90% of 80, and then we don't have to do the subtraction at all. We could just look for 90% of 80. Or, as I said before, we can replace that of with a multiplier. 90% of 80. And again, we can type that into our calculator using the percent symbol, and we'll get the right answer. Alternatively, if you don't have a percent symbol, remember, what does percent mean? Percent means per 100, out of 100, divide by 100. So this is 90 divided by 100 times 80. Or in other words, let me scroll, 0.9 times 80. And again, this will all just give us £72 she paid for the printer. How much did she pay for the hard drive? Well, she paid 20% more than Harry, and Harry paid 25. So rather than doing 25 plus 20% of 25, we're going to know that if we had 100% and we add 20%, we're going to get 120%. So we can work out 120% of, I'm just going to write times straight away, of what Harry paid, which is £25. And again, type that straight into our calculator, or we can use our multiplier, 1.20 times 25. It'll give us the same thing. The multiplier comes from taking the percent and dividing by 100. We're replacing the percentage symbol with dividing by 100. So when we type that into our calculator, what do we get? We get £30. So finally, to know how much she paid in total, we can add those two together. So 72 plus 30, we can say total for Ellie is 72 plus 30, which is 102. And the total for Harry then would be 80 plus 25, which is 105. So she did, in fact, pay less. So is she correct? No, she's not correct, because she paid less than Harry did. Now, always double check when you're ticking the box that you've reread the statement, because lots of people will do all of the right calculations, get to the end, work this out correctly, and then tick the wrong box. Don't do that. Don't be that person. I've done it, and it just makes you feel bad when you go through the answers afterwards. So if you're going to do the effort of doing all of the correct working, tick the right box. Sounds silly, but more people make the mistake than you might expect. Question 11. So we've got this shape. A shape is made by joining a right-angled triangle to a rectangle. So we've got the right angle on top, we've got the rectangle on the bottom. Work out the area of the shape. So we can work out the area of the triangle pretty quickly. It's area of a triangle. Oh, I've just realized I spelled that wrong. Area of triangle. Well, we know that that's a half times the base times the height. Yes, you can think of this as the base and this as the height, but actually, base and a height just need to be at a right angle to each other. So we can use this as the base and this as the height, and that works. So this is actually a half times 16 times 30, which is 240, I think. Yeah. So 240, and then what's our unit? Our unit is centimeters squared. So that's the area of the triangle. That was really easy. That was really quick. We're done. Except we're not, because we need to work out the area of the rectangle next. How do we work out the area of the rectangle? Well, normally that's easy. We do one side times the other side. But we don't know how long this side is. So we need to work that out. So I'm going to label this side C, and we're going to work out what C is. The reason I've chosen to label this side C is because with the right angle triangle, when you know two sides and you want to know the third side, we need to use Pythagoras' rule. So the Pythagoras theorem which I'm just abbreviating as THM. Pythagoras theorem says a squared plus b squared equals c squared. This only applies to right angle triangles, and you have to be very specific about which side is C. Which side is C? It's always the hypotenuse. So C is the hypotenuse. Or in other words, the longest side. It's the side that isn't touching the right angle. That's why I decided to label this side C, because these sides are shorter than this side. We know that this is the hypotenuse. So I've labeled it C, which means I can choose this as A and this as B, or the other way around. It doesn't really matter. So we know that 16 squared plus 30 squared is C squared. We're going to type that into our calculator. 16 squared plus 30 squared. We're going to get 1,156 is C squared. And note that this is C squared, not C. So we've got to remember to square root it. So square root of 1156 is C. And again, this is a valid step to make because what we're doing is we're square rooting both sides of the equation. We're doing the same thing to both sides, so we're keeping that equal sign valid. So we've got the square root of 1156, and if you type that into your calculator, you'll find that it's 34. So C is 34, which means we can work out the area of the rectangle now, because we know that one side it was 52. So it's 34 times 52, which is 1,768 centimeters squared. Don't forget your units. So to finish, we want the area of the whole shape. So we're going to add the area of the triangle, and we're going to add that to the area of the rectangle. So the two areas together, 240 plus 1768 gives us 2008. And that will be our final answer. And they've even given us the units for us. So very kind of them. Next question. Question 12. So we've got 4y equals 5x. There's a statement that they're telling us is true. 4y is 5x. Now they want us to use this statement to figure out which of the following statements is true. Is y 80% of x, 125% of x, 20% of y? Is x 20% of y, or is x 400% of y? Now, the way to work this out is, remember, we would love to be able to write y equals some percent of x. And we know that the of symbol can be replaced with a times. And we know that the percent symbol can be replaced with dividing by 100. So we want to find a way of having y equal to some number divided by 100 times x. That's what we're looking for. So let's start with the statement we've got. We've got 4y equals 5x. That's what we're aiming for. 4y equals 5x. What do we do first? Well, we wanted y on its own, so let's divide by 4 so we can get y on its own. We also have to divide the other side by 4 to keep the signs equal. That's 5 over 4x. Not the cleanest 4 I've written, but 5 over 4x. But now we want this as a number divided by 100. So what can we do to the top and the bottom to make the bottom equal to 100 of this fraction, 5 over 4? Well, 4 times 25 is 100. So we're going to times the bottom by 25, but we don't want to break the inequality. So we can't just freely times the bottom by 25. We also have to times the top of the fraction by 25 to keep it an equal fraction. So we're going to get 5 times 25 over 4 times 25, x. And y still on the left. We haven't changed the left. Now we're going to do those two multiplications. We're going to get 125 divided by 100. And now you see we've got it in this format. And we said this number is the number that goes before the percentage of x. In this case, this number is 125. So we know that y is 125% of x. That's what we've just worked out. We can even undo it this way. So we can say, well, we've got 125 divided by 100. That's the same as writing 125%. And it's being multiplied by x, so we can write of x. And that is exactly what this second box is telling us to say. So we can tick it. It's worth saying that we could have done this the other way around. So we could check if we were looking to get x as a percentage of y instead. We could do the same thing. We could start with 5x equal to 4y, divide both sides by 5. So we get x is 4 over 5y. And then if we turn that into a percentage, we're going to times the top and the bottom by 20. So we're going to get 80 over 100 y. So x is 80% of y. But that is not one of these options. So we know that we found the right solution. That's our little check that we could have done. All right, moving on then to question 30. We're about to reach the halfway point. I don't think there's too many questions here. I think it's probably like 25. Let me just double check. 25, 28, maybe? Ooh, 29. Okay, so we've got 2 more questions till we're halfway. So, question 13. We've got some 3D shapes here. We've got an ice cream cone. Outside a cafe, there is a large plastic ice cream cornet. The cornet is a hemisphere on top of a cone. So, hemisphere is half a sphere. Hemi meaning half. Sphere is the ball that you're used to. On top of a cone. Cone is the circle at the bottom, drawn to a point. The cone and the hemisphere each have radius 24 centimeters. The cone is perpendicular height 117 centimeters. So what does this tell us? We're even actually given 2 little helpful boxes here as well. We're given the volume of a cone and the volume of a hemisphere. So we can use those to work out the volumes that we're looking at. But we've not been told to work anything out yet. So let's go read the questions. What is it that we're being asked to do? So part A, work out the total volume of the cornet. That's what we need to do. Total volume. So the question tells us that it's a cone plus a hemisphere. And we're told the volume of a cone formula and the volume of a hemisphere formula. Let's substitute the radii that we have and the height that we have, the radius that we have and the height that we have, and work out what those are. And then we'll add those 2 together for the total volume. So, cone volume, we've got 1/3 times pi times the radius, which we're told is 24 squared, because it's squared in the equation, times the height, which is this here, 117. So that's just me taking this. We've got 1/3 pi r squared h. Type that into a calculator and we get, I'm not going to put the pi in because I don't want to deal with the decimals yet. So just putting the other numbers in, we're going to get 2.2464 times pi centimeters cubed. And it's centimeters cubed because it's volume. So volume has centimeters cubed, area is centimeters squared. Moving on, the volume of the hemisphere. So hemisphere volume. And again, we're looking at 2/3 pi r cubed is what we're told. So we're going to write that down. We're going to do 2/3 times pi times r, which is 24. Remember, we were told that here, cubed. And when we type those numbers into the calculator, we get 9,216 pi centimeters cubed. So total, we're going to add the two together. So we're going to do 9216 plus 22464. And remember that we're timesing by pi. And our final answer is going to be 31680 pi centimeters cubed. And it's perfectly valid to leave the number pi in your answer. That's okay. It didn't say to tell you to three significant figures or anything like that, so you didn't need to make it a decimal. However, if you wrote it as a decimal, you could have written, 99525 or 526, I can't remember, centimeters cubed, and that would have been fine. You just round it to the nearest number or even to the nearest three significant figures. You can do that. All of those answers will be valid in the mark scheme. I just like keeping it exact because in a non-calculated paper, that's probably what you're expected to do. I didn't write the final point. The final point was that we add the two together. So it's there you go. There's the final bit. All right. So for part B, then we're told, the actual coordinates that the cafe sells are similar to the plastic one. So similar here, they've made in bold. What does that mean? Similar means mathematically similar. It means that the object has all the same proportions. It just might be smaller. Well, I'm going to assume it's smaller, seeing as we were told it's a large plastic cone outside and they're selling the smaller one. So you wouldn't want to. Anyway, so we've got similar plastic cones, and these ones are much smaller. But they've got all the same dimensions. So it's a hemisphere and it's a cone. So the actual coordinates for the ones they sell, the small ones, the cone and the hemisphere each have radius 2 centimeters. So before we were dealing with radius 24 centimeters, now we're dealing with radius 2 centimeters. How many times greater is the volume of the plastic cornet than an actual cornet? So what we're looking at here is a scale factor. What is the ratio? Well, the radius of the small to big is 2 to 24. And because we're similar, that means we're similar in all proportions. So if the radius is that difference, then the height will also be by the same ratio. And so when you do the volume calculation, you're using each of those lengths, which are one-dimensional, and you're multiplying them 3 times. So if you look here in the volume of a cone, we had r squared times h. So we had r times h. That's 3 different lengths multiplied together. And the same here, we had r cubed. So r times r times r, 3 lengths multiplied together. So you take one dimension times the second dimension times the third dimension, which means that when your lengths are changing by a certain ratio, that change is happening 3 times. So while your length scale factor, so what you're multiplying by to get from 24 to 2, we're being asked how many times greater. So when you're going from 2 to 24, the length scale factor is times 12. So we're timesing by 12 to get from 2 to 24. But when you do the volume scale factor, that scale factor is happening on all 3 lengths that are being multiplied together. So your number is actually becoming 12 times 12 times 12 bigger. So 12 cubed is your volume scale factor. Just quickly, this does also work for area. So area scale factor would be 12 squared because you've got one length and another length. So it's happening twice. But we're caring about the volume scale factor. So it's 12 cubed. And then we just type that into our calculator and we'll find that it's 1728. At least that should be right. 12 cubed. Yes, 1728. And that's it. That's how we answer that question. So volume scale factor is what happens when you go from a volume to another volume. And it's always the cube of the length scale factor. So it's really handy to know that. It comes up quite a lot. We could, of course, have worked out using these. We could have worked out the volume of the smaller cone and then just done the bigger cone divided by the smaller cone in its volume. But that would have required us to find the smaller height, which does require us to use this ratio anyway. So instead, we're going to skip all of that and we just do the volume scale factor, and it's much nicer. Moving forwards. Question 14. So we've got a pie chart. A survey was held in a football stadium. A sample of the crowd was asked about the importance of a family area. The pie chart represents the answers. So we've got what looks like about a sixth saying not important, what looks like about a sixth saying quite important, and what looks like about 2/3 saying very important. Now, crucially, these are never drawn to scale. Unless they say it's drawn to scale, you always have to assume it's not drawn to scale. So saying it looks like about a sixth and about 2/3, that means nothing. And measuring it with your protractor is a valid way of doing it, if it was drawn to scale. But in this case, we're actually specifically given the numbers. So we don't need to do all of that. We don't need to worry about it. We don't need to approximate. We're given the specific numbers, so we're going to work with the specific numbers. Part A. The total number of people in the crowd was 29,250. Estimate how many people in the crowd think that a family area is very important. So the reason it says estimate here is because we didn't ask all 29,250 people. We asked a sample of those people. So we just took a survey of a sample of those people, and these are the results we got. You can see how many people said yes to each of them. So we're estimating because we're assuming that this sample is representative of everybody there. We're assuming that if we did actually ask every single person there, the ratios would be exactly the same. That's an assumption, which means that we are estimating. We don't actually know, we can't work it out. So it doesn't mean estimate as in guess. It means do the calculation and work it out. But we're saying estimate because we recognize that it's not a accurate calculation because we haven't actually asked everyone. We haven't actually asked every single person in the stadium. And unless we do that, we wouldn't know for sure. So it's an estimate. And actually, that's what the second line says. It says, assume the sample is representative. That's why it's an estimate, because you're assuming something. You can't assume something and then say definitively that it is this way. So how do we do this? Well, we're going to need to work out the total number of people they asked. So total people surveyed is just simply adding up those numbers. And when we add up all of those numbers, we should get 2,250. So they asked 2,250 people. That is quite a lot of people. It's probably a fairly accurate sample. Because the more people you ask, the more accurate your sample is, the more representative it is. So now we're going to look at the relative frequency of the thing we're being asked about. So we're being asked about very important. So what's the relative frequency of very important? Which I'm going to write as rel freq of very important. Well, we're going to take the frequency and we're going to divide it by the total. That's our relative frequency. Then our estimated frequency, which I'm going to write as est freq of very important, is going to be taking that relative frequency and multiplying it by the new total. So we do 1475 to 250, and we multiplied that by the new total, which is 29250. Type all of that into a calculator, and we get 19175. And that will be our answer. So 19,175 people is what we estimate. In part B, we're told that actually, in fact, 50% of the sample were sitting in the family area and 10% of the crowd were sitting in the family area. So that means that half of the people we asked were sat in the family area, but the family area is only 10% of everybody who was at the game. So what is this likely to mean about the actual number of people in the crowd who think a family area is very important? Well, it means that we asked people who are biased. We asked people in the family area. So a higher proportion of people in the family area will say, yeah, the family area is important because that's why they're there. So if we did a better spread, if we asked everyone, because they're not actually representative of the whole group. So if we asked everyone, we would in fact find probably that the proportion is lower. That actually, because not as many people will sit in the family area, we asked people who were sat in the family area, they're going to be biased to say that it's important to have the family area. That's why they're there. So if you ask people who aren't sat there, they're going to be less biased. And the fact that we asked 50% of the people we asked were in the area means that we over asked people from that population. We would try to normally ask a representative sample, but we didn't skew it correctly. We got too many people from the family area and not enough people from outside of it. Because 50% doesn't match with 10%. It's too many. So that's why it's this way. Question 16. Amal owns a sandwich shop. The sandwich shop is open from Monday to Saturday, so 6 days a week. In June, Amal sold 3,000 sandwiches. Part A. He wants to work out the mean number of sandwiches he sold per day in June. So that requires you to know there are 30 days in June. He took 3,000 sandwiches and divided it by the 30 days in June and got 100 sandwiches a day on average. What's the criticism we can make? Well, yes, there are 30 days in June, but he wasn't open for 30 days in June. He's only open Monday to Saturday. So if he's only open 6 days a week, then he will have actually sold more than 100 sandwiches because he's averaging for days that he didn't sell any sandwiches. So his actual number will have been higher. So the criticism we can make is he was only open 6 days a week. He's assuming he's open every day. Or you could say, there's lots of different ways you can make the criticism, but that's the crux of it. So you can say he accounted for 7 days when he should have accounted for 6. You could say his actual number of sandwiches sold per day will be higher because he only is open 6 days a week or something like that. Anything to do with those is a valid criticism. Please let me scroll. So he received £6,660 from selling the 3,000 sandwiches in June. The numbers of sandwiches sold were in the ratio meat to cheese to vegan, 9 to 4 to 7. The price of a meat sandwich is £2.39. The price of a cheese sandwich is £1.89. Work out the price of a vegan sandwich. So we're given the total amount of money he spent. Sorry, the total amount of money he made. We're given the total number of sandwiches he made. We're given the ratio of the 3 types of sandwiches he made. And we're told the price of 2 of the 3 types. And we want to work out the price of the third. Well, first thing we can do is we can size this ratio up to 3,000. So at the moment, 9 plus 4 plus 7, we've got a total number of parts of 20 parts. So at the moment, we've got 20 parts. But he didn't sell 20 sandwiches, he sold 3,000 sandwiches. So let's scale that up. 3,000 sandwiches. How do we get from 20 to 3,000? Well, I'm going to type into my calculator 3,000 divided by 20. I could do it in my head, but I always like to check. So that's 150. So we're going to need to multiply each of those numbers by 150 to scale them up. So we do 150 times 9. We get 1350, or 150 times 4, which is 600, and 150 times 7, which is 1050. And again, you could do all of that in your head or on a pen and paper, but using your calculator just avoids mental math error. So it's just better to get into the habit of using it when you have it. So that's how many how many sandwiches he actually sold of each type. He sold 1350 meat, he sold 600 cheese, and he sold 1050 vegan. Now we can work out how much money he made from the meat and the cheese, and then we can work out how much money is left to work out how much the vegan sandwich cost. So 1350 times £2.39. That's how much money he made from the meat sandwiches. We're going to add that to 600 times £1.89. That's how much he makes from the cheese sandwiches. So what is that when you add those together? I haven't actually worked this out in advance, so I'm going to do it in my calculator now. 1350 times 2.39 plus 600 times 1.89. That is £4,360.50. Now we're going to take that away from the total. So 6660 minus 4360.5. Which gives us 2299.50 pounds. And that's how much money he will have made from the vegan sandwiches. So he made that much from the vegan sandwiches. So what do we need to do now? Well, we know that he made and sold 1,050 vegan sandwiches. We know that he made that much money from them in total. So how much money did he make from each of them? We divide that money by the number of sandwiches to get £2.19. So 2299.5 divided by 1050 gives us £2.19 per vegan sandwich. And that is our final answer. So we can go write that down here, £2.19. Try and make that 9 a bit clearer. Always want to make sure your notes are as clear as they can be, because you want to make the examiner's life as easy as possible when they're marking. So if you write a 9 that looks like a 7, like I just did, if you've got time, rub it out, write it again as a 9. It will help your cause. But don't make your corrections make it messier than it was originally. If it becomes too much, cross it out, write it again underneath. So 17. Good news, we're past the halfway point. We only had 29 questions, we've done 16, so we're past the halfway point, we're golden. 17, nice short 1 marker here. Here is the plan of a solid. Which solid could it be? So what is a plan? A plan means a view from above, usually, but it could be a view from the side. It's usually a view from above. Which of these could it be? Well, if you looked at a sphere from above, it would just look like a circle. If you looked at a cone from above, if you're looking down the point, it would also look like a circle. If you're looking from side on, it would look like a triangle. If you look at a hemisphere from above, it's going to look like a circle. If you look at it from the side, it's going to look like a semicircle. So cylinder is the only option, because if you look at a cylinder from the circular side, yes, it looks like a circle. But if you look at it from the other side, it looks like a rectangle. So cylinder is our answer. Nice and easy. Okay, 18. It's another question where we're asked to solve an equation. What we've got here is a quadratic equation. We've got x squared plus 7x minus 11 equals 0. Now, often with quadratics, we'd love to try and factorize them. And sometimes that's worth doing. This is a calculator paper, though, which means that we're welcome to use our calculator as much as we want, which means we can do whatever shortcuts we want, which means the easiest way to do this is using the quadratic equation. So, do we remember what the quadratic equation is? X equals minus b plus minus the square root of b squared minus 4ac all over 2a. We need to know this. We need to know this. It's an essential equation. But what are a, b, and c? So these are for a quadratic equation of this form. So when you have a in front of the x squared, b in front of the x, and c in front of the, c as the units, and then the whole thing is equal to 0. That's when you can use the quadratic equation. We have that here. In our case, we've got a as 1, because we've got nothing in front of the x squared, so we've got 1 times x squared. We've got b as 7, because we've got a 7 in front of the x. And then we've got an 11 on the end, except it's not an 11, it's a minus 11. So you have to remember the minus sign. So C is minus 11. And that would have gone for the A or the B. If we had a minus in front of any of them, we would have needed to keep it. It's essential you don't lose that minus sign. So now we get to substitute. So every time we see a B, I'm going to write a 7. Every time we see a C, I'm going to write minus 11. I'm just going to write it down. So minus 7 plus or minus the square root of b squared, which is 7 squared, minus 4 times a times c. I'm going to write minus 11 in brackets there, just because I want to make sure the minus is part of the 11. And then don't forget, it's all divided by 2 times a, which in our case is 1. So you can put this straight into a calculator like this, as long as you're very careful with how you write it. That's probably the best thing to do. Alternatively, you can go, okay, well, it's minus 7 plus or minus 49. And then the minus 4 times minus 11 becomes plus 44. So it's 49 plus 44. All over 2. And then you could put that into your calculator. Again, my 9 looks not like a 9. Or you could do the 49 plus 44 and then put it in your calculator. It doesn't really matter. But the point being, be accurate. Whatever you do, at whichever point you decide to put it into a calculator or not, just make sure what you're doing is accurate. If I'd made an error here with my negative signs and I'd left this as minus 44, that would have been worse than just typing this in like this, because the calculator would have sorted the negative signs for me. Just be accurate. There's no point losing silly mistakes. Check your work as you go. All right, so now we've got this. We've typed it into our calculator. Well, actually, sorry, some of you might be like, how do I type this into my calculator? It's got this symbol in it. This means you've got 2 solutions. You've got the solution where that symbol is a plus, and you've got the solution where that symbol is a minus. So you type them both into your calculator separately. You type it first with a plus, write down what you get. Then you type it in with a minus, write down what you get. So also, by the way, where I've not been writing the left-hand side, it's assumed that it's the same. I'm just like the X is continuing down the same. I just am not writing it to save myself time. And as long as you keep your equal signs lined up, the examiners will understand. But if you do something that changes the right-hand side, you can't leave the left-hand side unwritten because it has changed. You need to change the left-hand side as well to match what you change on the right. This isn't changing the actual answer on the right. It's just changing the way that it's presented. So it's still equal to X. Okay, rant aside. We've typed it into our calculator and then we've rounded to 3 significant figures. Just because, you know, they're complicated decimals. If it doesn't say what to round to, assume it's 3 significant figures. So we get 1.32 or minus 8.32. And we write in brackets that we did that to 3 significant figures. That's supposed to be 3SF, but it's really not very clear. 3SF. And that's your answer. So there's 2 solutions, and they do actually say solutions plural, so that should hopefully take you off to being like, oh yeah, there's 2 solutions. All right, 19. Okay, in my notes, I've written one method of doing this, and then I've starred it and said, there's a simpler way to do this. So I'm going to do it not looking at my notes and see if I did it in the simpler way. I'll explain what the other method was later if I did it differently. So A, B, C, D, and E are points on a straight line. A, B, C, and D are equally spaced, but A to D and D to E are in the ratio 2 to 1. So what that means, here to here is the same distance as this, is the same distance as this. These are all the same. But here to here is twice as long as here to here. Now, okay, I'm going to do this in the simplest way, I think. How far down and how far to the right do we go when we go from A to B? Well, down is in the y coordinate, which is the second coordinate. So we've gone 4 down. So I'm going to write minus 4. And then in terms of to the right, we've gone from 5 to 11. So we've gone 6 to the right. That means we're going to do the same thing here. Minus 4 and 6. Same thing here, minus 4 and 6. So then, to get from A to D, oh, that's maybe not the best way to do it. To get from A to D, we've gone down 4 3 times, so minus 12. And we've gone to the right 6 3 times. So we've gone 18. That's how we got from A to D. Now, if A to D is twice as much as D to E, that means that we take the A to D and we just cut it in half. So instead of 18 to the right, we're going to go 9 to the right. And instead of 12 down, we're going to go 6 down. Now, to work out the coordinates of E, we can take the coordinate A, which is at 526, and we know that we're going 18 to the right and then 9 again to the right. So we've got 5 plus 18 plus 9, which we can use our calculator for. 5 plus 18 plus 9, just making sure that we're being accurate. And then we know that we're going down 12 and then down 6. So 12 plus 6 is 18. So we've gone across 32 and we've gone down 18. So we're gonna oh sorry, I forgot to say that we're let me do these bits again. We were going down 18, yes, but we were starting at 26. So it was 26 and we were minusing 12 and then minusing 6, or 26 minus 18, same thing, which gives us 8. So that's the whole thing. We now know that the x-coordinate of E is 32 and the y-coordinate of E is 8. So we can write that down, 32, 8, and we're done. The original method that I'd done in my calculations, which was far more complicated, was I used A and B to work out the gradient of the line. Then I found the equation of the line. And then I started doing something else that was entirely unnecessary. And in the end, I basically did this anyway. So I could have just done this from the start, like I showed you. So the other method was much slower, much worse. This is the best way to do it. To summarize, to get from A to B, you're going down 4 and across 6. And if A, B, C, and D are equally spaced, then A to B is the same as B to C is the same as C to D. And then we're told that A to D is the same as twice D to E. So we see what A to D is as a total, halve it to see what D to E is, and then we just need to work out, well, how far have we actually traveled along X from A, and how far have we actually traveled along Y from A to get to E. And we're done. Question 20. So a company makes and sells boxes of washing powder. The company wants to increase, and we can see a lovely diagram here. It says washing powder, £1.68, sorry, 1.68 kilos, £5.60. Company wants to increase the amount of money it receives per kilo of powder. To get the required increase, it can either increase the price to £5.88 or reduce the mass of powder in the box by X%. And we're asked to work out the value of X to two decimal places. So again, a lot of words. Let's try and figure out what the words are saying. So, sentence 1. Company makes and sells boxes of washing powder. Cool. That has no mathematical meaning. We can basically disregard it. Sentence 2. The company wants to increase the amount of money it receives per kilo. So we want to increase the amount of money per kilo. So at the moment, they're selling 1.68 kilo and earning £5.60 per 1.68 kilo. They want their price per kilo to go up. So they can either increase the price or reduce the size of the box. And we're asked to work out by how much would they have to reduce the size of the box to get the same increase in price. Cool. So let's get stuck in. So we're told that 1.68 kilo costs, let me write with some neat handwriting, costs £5.60. Now, what is the price per kilo? So the price per kilo, because that's what they want to go up. But the price per kilo currently is £5.60 divided by 1.68, which your calculator will tell you is 10 over 3. And I'm going to leave it as a fraction because I like it being exact. So it's 10 over 3 pounds per kilo. Now that we know, actually, I'm just going to double check because I don't think I ever checked that, right? 5.6 divided by 1.68. Yes, 10 over 3. So we've got 10 over 3 pounds per kilo. Then the increased price per kilo, so that's our current price per kilo, our increased price per kilo is 5.88. So that's what they want to go to, 5.88 divided by 1.68, which is 7 over 2 pounds per kilo. I'll just assume that one's correct. If your calculator tells you something wrong, it's very feasible that my calculator was incorrect. Well, it's not that my calculator was wrong. It might be that I wrote down the wrong thing. Then mass needed for increased pounds per kilo. So we've worked out the current price per kilo and we've worked out the increased price per kilo, the price per kilo they want to get to. So 7 over 2, 3.5 is bigger than 10 over 3, 3.3 recurring. So they just want that to bump up a little bit, that price per kilo. So if we sold it for the same amount but reduced the amount that was in the box, how much do we have to reduce the amount in the box by to get 7 over 2 as our price per kilo? So we're going to look for the mass needed for 7 over 2 pounds per kilo. And the way that we're going to work that out is we're going to take the current price and we're going to divide it by the pounds per kilo to work out how many kilos we need. So this is another one of those that you can think of as a box, right? The triangle. You had pounds per kilo, a kilo. To work out the number of kilos that you need, you cover that and you get pounds divided by pounds per kilo. And that's how we do it. It's the same as the speed and the distance and the time, you know. So we're going to take £5.60. We're going to divide it by 7 over 2, or by 3.5, same thing. And that's going to give us 8/5 kilos. Now, actually, I'll leave 8/5 as a decimal this time because it's not a complicated decimal. It's 1.6. So 1.6 kilos. So we know then for the current price to give us the price per kilo that we want, we just need to drop it from 1.68 kilos to 1.6 kilos. It's not that big a difference. But what is that as a percentage? So the reduction is 0.08 kilos. So reduction amount is 1.68 minus 1.6, which is 0.08 kilos. Now, you might see that and be like, oh, that looks like a percentage and think that's a percentage. No, that's just a number of kilos. So we need to work out what is that number of kilos as a percentage of the original mass. So the original mass was 1.68. So we're going to do this amount divided by the original amount and then times 100%. So 0.08 divided by 1.68 times 100%. Now, you may be used to writing this just as times 100 and not having that percent sign, or you might just be used to doing it as a decimal and then being like, and that's this much percent. Or you might remember what I said earlier about percentage sign meaning divide by 100 and being like, but 100% then is just 1 if you write both. And I'm like, well, actually, yes, that's the point. I don't want to change this number. So I'm multiplying by 100%. 100% is 1 because I don't want the number to change. I just wanted to be able to write it with a percentage sign afterwards. So if I write it with the percentage sign afterwards, then I have to multiply it by 100 to make it still the same number. I'm sort of undoing the dividing by 100 that the percentage symbol does by multiplying by 100 in the first place. If that didn't make sense, don't worry. It's just doing the percentages like you normally do. I'm not doing anything crazy. So you do this, and your calculator, if you type this into your calculator, by the way, it will not give you a percentage. You only type this bit into your calculator, and then you write the percentage symbol. That's why most teachers don't teach you to write the percentage symbol at all. They just write that. But I trust you to be able to know that you don't write 100% into your calculator at this point. You just write 100 and then you keep the percentage symbol because otherwise it would disappear. So final answer then, 4.76%, because we're asked to round to 2 decimal places. So make sure you actually round to 2 decimal places, not 1 or 3 or anything else. That's our final answer. Okay, we're so nearly there. We have 9 more questions. And some of these are 1 mark, so we might fly through them. Which of these is the equation of a circle? That one. The equation of a circle always has the format x squared plus y squared equals r squared. This is the only one that looks like that. This is, in fact, a thing called a hyperbola. It would look like that. This one will actually look like a circle. This one it's not got a y squared, it's just got a regular y. So that's just a normal quadratic graph that's been shifted down by 6. And this one, same story, but it's a quadratic graph that's been shifted up by 6. So this one is the only one that is an actual circle. Moving on then, 22. Circle the reciprocal of 8⁵. What does reciprocal mean? Reciprocal means 1 divided by that number. So the reciprocal of a 5th is 5. The reciprocal of 5 is a 5th. So what is the reciprocal of 8⁵? It's 1 divided by 8 to the 5. But how do we represent that as an index? This is the point of negative indices. So when you have x to the minus 1, that is 1 divided by x. When you have x to the minus 3, that is 1 divided by x cubed. The minus means make it a reciprocal. Make it a 1 over something. And then the rest of the number tells you what to leave as your power of x on the bottom. So we're doing this in reverse, effectively. We're saying, well, we have a 1 over 8 to the 5, and we want to make this an 8 to the power of something. That's what this negative symbol is for. So it's negative 5. There. All right, moving on again. 23. Factorize 3x squared minus 16x minus 12. So unfortunately, the best method for this is to be able to just see it, to just like get it and guess. You know that you're going to get 2 sets of brackets because it's a quadratic and you're being asked to factorize a quadratic. You'll always get 2 sets of brackets. You know you're going to get an x as the first thing in both of them. But you also know that because you've got a 3 in front of that x squared, one of them is going to have a 3 in front. If it was a 6, one of them might have a 6 in front. One of them might be a 2 and the other a 3. It's harder to know. But with a 3, it's a prime number. They're asking you to factorize. They're not going to ask you to go into anything more complicated than whole numbers. So it's just going to be a 3x and a 1x. Then we also know that the second bit here, these 2 numbers are going to multiply to make minus 12. So what numbers multiply to make minus 12? Well, we've got 1 and 12. Well, minus 1 and 12, 1 and minus 12. We've got 2 and minus 6, or minus 2 and 6. We've got 3 and minus 4, or minus 4 and 3. Those are the sets of numbers that multiply to make minus 12. And now what you need to be able to do is see, well, which of these can I choose as a pair that will give me the middle one when I expand it? And you can do it by trial and error. Or there's a slightly more reliable way of doing it. And the slightly more reliable way of doing it is to say, well, instead of looking for things that make 12, we can do 3 times 12 and look for things that make 36. So I'm going to draw a line here. So minus 1 and 36. Or, in fact, I'm not going to write all of the minuses. I'm just going to write 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't go into it, 6 and 6, 7 doesn't go into it, 8 doesn't go into it, 9 and 4, we've gone back up the other way. So we've gone back up this side by now. So these are our pairs. One of them will be negative, one of them will be positive. And which of these can we add as a pair to make 16? This is the only pair because minus 18 and 2 make 16. There's no way to make 3 and 12 make 16. They make 15. 4 and 9 won't make 16. 6 and 6 won't make 16. When you add them together, 1 and 36 won't make 16. But 2 and 18, if you make the 18 negative and the 2 positive, you'll get minus 16 out as we need. So then we can just write that down. So we can write 3x squared minus 18x plus 2x minus 12. And then we can look at factorizing this. So we factorize that first and then factorize that. So for the first bit, we can take a 3 out because 3 and 18 are both divisible by 3. We can take an x out because they're both, one's got an x squared, one's got an x. What's left? We've got an x from the 3x squared, and we've got a 6 from the minus 18x. What about for the other one then, for this bit? Well, they're both divisible by 2, but that's about it. So we're going to add 2, and then we're going to take x minus 6. And now, if this factorizes correctly, this bracket will be the same as that bracket, Joy it is. So we can now know that one of the brackets is going to be x minus 6, and the other bracket is these two bits combined, so 3x plus 2. And that's it. That's how you answer it. So you can write this then, 3x plus 2, x minus 6. To summarize this method, because if that's the first time you've seen that method, that is not going to be a clear way of explaining it. So to summarize this method, when you have ax squared plus bx plus c, you can look for factors of AC. So you take the first number, you multiply it by the end number, and you look for factor pairs of these two numbers multiplied together. So in our case, we had 3 and minus 12, so we were looking for factor pairs of minus 36. List all your factor pairs, and then you need your factor pairs to add to B. So you want factor pairs of AC that add to B. Or I guess that sum to B is slightly better wording. So you're looking for factor pairs of AC that sum to B. Then once you've got it, you write it down with the split up X. So you've taken that B and you've split it into the two factor pairs that you found. So we had our minus 16x here, and we split it into minus 18x and plus 2x. And then you were factorizing that. That's how to do that. If you can't do that, but you can spot it, great, go for it. Learning how to do this is useful. It's the only sort of reliable method to solve these types of questions. Other than, of course, it's a calculator paper. What else could you do? You could use the quadratic formula. If you use the quadratic formula, I'll just show you this quickly. Use the quadratic formula. So you get minus b, which becomes plus 16, plus minus the square root of b squared, so minus 16 squared, which is 256. B squared minus 4ac. So that's 4 times 3 times minus 12. So minus times minus is a plus. 4 times 3 times 12 is 12 times 12, 144. And then all of that divided by 2a, so 2 times 3, so 6. If you do that in your calculator, so what's 256 plus 144? That's 400. So when you square root that, you get 16 plus or minus 20 over 6. So your options are 16 plus 20 over 6, which is 36 over 6, or 6. And the other option is 16 minus 20 over 6. So that's minus 4 over 6, or minus 2/3. So those are your two solutions. And you know that it's factorizable, so you know you might get a number out the front, which I'm going to use a capital A just to say there might be a number out the front. But then you're going to get x minus the first root, 6, sorry, not plus, times x minus the second root, and x minus 2/3. But then, of course, that is a valid factorization if you do this and you find the number that you need here to make, which would be 3. It would be 3. You could do that and put 3 out the front, because you know that x times 3 needs to give you 3x squared. So that's a valid factorization, but I think you want to make it look nice. And the way to make it look nice is say, well, if you're minusing a minus, let's just make that a plus. Let's just replace that minus a minus with a plus. And then also, if we've got a 3 out the front and a 2/3 in one of the brackets, let's just bring that 3 and put it into the 2/3 bracket. So we're going to multiply both of the things in there by that. This is the same as x minus 6, and then 3 times x, and 3 times 2/3, which is the same as what we found. Yes, the two brackets are the other way around, but because you can multiply in any order, like 3 times 5 is the same as 5 times 3. So it doesn't matter which way around we write the brackets. So yeah, I wanted to show you just the different method. The quadratic formula will find you. If you really can't see how to factorize it and the other method isn't working, use the quadratic formula, find the roots, and once you've found the roots, then you can just, the roots are the solutions. Once you've found the solutions, then that will let you write down the equation like this. And then it might just be a case of making it look pretty. 24. So a straight line is a A straight line is perpendicular to the straight line through 2, 8, and 6, 15, and passes through 0, 9, and x, 17. Work out the value of x. So what are we supposed to do here? Well, let's try and understand what it says first. We're looking at a straight line, and we're told that this straight line is perpendicular to this other straight line. So let's call the first straight line L1 and the other straight line L2. Pardon me. L2 goes through 2, 8, and 6, 15. What's the gradient of L2? Because if we're looking at L1 being perpendicular to L2, then we want to know the gradient. So the gradient, by the way, is the measure of how steep a slope is. So the gradient is calculated by the change in y over the change in x. So I'm using a triangle symbol to literally replace the words change in y divided by change in x. So it's the vertical change divided by the horizontal change. For L2, the gradient is, what's the change in y? Well, that's 15 minus 8. What's the change in x? Well, that's 6 minus 2. So 15 minus 8 is 7. Yes. 7 divided by 4. I'm just going to leave it as a fraction again. 7 over 4. That's our gradient. And we're told L1 is perpendicular to L2. Now, what does it mean for two lines to be perpendicular? Well, if two lines are perpendicular, they meet at a right angle. Let's get that first. So they meet at a right angle. What do we know about the gradients of two lines that are perpendicular? The gradients of two lines that are perpendicular will multiply to make -1. So perpendicular to L1, this means therefore gradients of L1 and L2 will multiply to make -1. So if L2's gradient is 7 over 4, then L1 gradient is going to be -1 divided by 7 over 4. Make that one a bit bigger. -1 divided by 7 over 4. When we divide by a fraction, that's the same as timesing by its reciprocal, by flipping it. So -1 times 4 over 7, which is just -4 over 7. So the gradient of L1 is -4 over 7. Now we've been given, in the second bit of information, 2 points on the line. So we've got the x and y coordinate at the first point, and we've got the y coordinate at the second point. We need to find the x. So we know the gradient of L1, but we also could work out the gradient of L1 from the 2 points on the line, like we did with L2. So we can also say L1 gradient is also the change in y divided by the change in x, which in this case would be 17 minus 9 divided by x minus 0, or in other words, 8 over x. So we've worked out the gradient in two different ways. We've got minus 4 over 7, and we've got 8 over x. But these need to be the same. It's a straight line, it can't have two gradients. These have to be the same. So we can write that down. 8 over x equals minus 4 over 7. And then it's just a case of finding x on its own. So I'm going to start by making x the top of its fraction by flipping both sides. So x over 8 is minus 7 over 4. And then what I'm going to do is I'm going to multiply both sides by 8 to get rid of the 8 on the bottom of the fraction. So x on its own, so I'm multiplying the left by 8. Have to do the same to the right. So we get minus 7 over 4 times 8, which is minus 14. So x is minus 14. And that is the end of the question. So to summarize, what did we do? We were told that we had two perpendicular straight lines. We were told that one line passes through these 2 points and one line passes through these 2 points. We worked out the gradient of the line that we knew both points on. We then worked out the gradient of the other line because perpendicular lines multiply, the gradients multiply to make minus 1. So we could work out the other gradient. Then we worked out the gradient again using a different method, using the change in y over change in x method. And then we know that those two ways of calculating the gradient have to both be equal. So we can make them equal, rearrange for x, and we're done. 25. I promise you it's not long left. There's only 29 questions, so we've got 4 more. We'll see. Yes, I counted on my fingers. It's 5 more. So 25. This is a function question. We've got the function f of x is equal to 2x plus 5. And we're asked to show that 3 times f of x minus 12 times f inverse of x simplifies to an integer. So, what is a function? A function you may have seen described as like a little machine. So it's like you have a box and you send something in and then you get something out. So x goes in and f of x goes out. So for this function, the function is 2x plus 5. If we put 1 in, for example, we're going to get 2 times 1 plus 5. So coming out, we're going to get 7. So the x is a placeholder, and what we do is we replace that x with whatever number we're inputting to the function. What is this minus 1 then? This, I said, was the inverse function of f. So inverse meaning opposite. So the inverse function is supposed to take you back to where you started. So if you've done f to something, so if you've taken 1, you've put it through f of x and you've got 7, you should be able to take the 7, put it into f inverse of x, and get the 1 back out. That's the hope. So how do we invert a function? Well, one way to invert a function is to say y equals 2x plus 5. So I've created a new placeholder, y, and I've just taken this function and I've said y is the output. X is the input, y is the output. And this is what the function says. But now let's make x the subject of the equation. If we rearrange and make x the subject, then we'll have the inverse function. So x, actually we'll do this in step by step. How do we get x on its own? Well, first we're going to have to take away that 5. So we're going to do that to both sides. We get y minus 5 equals 2x. Then we're going to have to divide by 2. So we'll have to do that to the other side as well. So x is equal to y minus 5 over 2. This is the inverse function. So f inverse of y is y minus 5 over 2. And it's because if you take 7, for example, if you take 7, put it into f inverse of 7, well, that is 7 minus 5 over 2, which is 2 over 2, which is 1. So it took us back to where we started. So it is an inverse function. It does work. We've checked it. And then this is just a sort of tradition thing, I guess. We'll typically write it with, that's not very clear, 7. We'll typically write it with an x instead of a y. So f inverse of x then is x minus 5 over 2. It's the exact same function, this inverse function that we found. I've not changed anything by replacing the y with an x. It's just that I've chosen a different placeholder. That's all I've done. And so for that reason, you might see teachers, when they teach this method, swap the x and the y already at the beginning, rather than what we just did and swap it at the end. It doesn't matter whether you swap it at the beginning or the end, you get the same output. So we found f, we were given f, and we found f inverse. Now, what we need to do is show this. How do we show this? Well, what it's doing is it's taking the function f of x, multiplying it by 3, and then taking the inverse function of f of x, multiplying it by 12, and taking that away from the previous thing you found. So let's write all of that down. So we're going to write 3 times f of x, which was 2x plus 5. That was at the top there. And we're going to take away 12 lots of f inverse of x, which is x minus 5 over 2. And now, so I'm going to just draw a line to separate that we're starting something new. Now we're just going to try and not change this answer. So this, we're just going to do things that keep it the same. We make it look simpler, but we're not going to change its answer, its value at the end. So we can expand these brackets on the left. So 3 times 2x is 6x. 3 times 5 is 15. And then I'm going to take this divided by 2. I'm just going to bring it out to this 12 here. So I'm going to get minus 6 lots of x minus 5. Because 12 divided by 2 is 6. Don't lose that minus sign. It's very important. So we get 6x plus 15. Now we're going to expand these brackets. Again, don't forget your minus sign when you're expanding. So it's minus 6 times x to get minus 6x. And then minus 6 times minus 5. So it's all of that times all of that. So you get plus 30. Now we can look for similar things. We've got a 6x here and a minus 6x here, so they're going to cancel. They're going to disappear. Then we've got a 15 and a 30. That makes 45. And what we were asked to prove was that it simplifies to an integer, 45, which is an integer. And then we're done. So to summarize, a function takes an input to an output. Inverse function takes the output back to the input, and we denote it with to the minus 1. And all we had to do for this question was find the inverse, write the thing that they want us to simplify down, and then simplify it. And we saw that we got 45, which is what they wanted. So 26. 2 objects, J and K, are applying pressure to areas of ground. They've given us this equation for pressure. Pressure is force divided by area. For J, the force is 18.9 newtons and the area is 0.45 meters squared. And then we've given these ratios. So the pressure for J to pressure for K ratio is 7 to 8. And the ratio of the area for J to the area for K is 9 to 5. And we're told to work out the force for K. So how can we do this? Well, let's start by looking at J. So if we're looking at J first, the area is 0.45 meters squared. We're told that. The force is 18.9 newtons. We're told that as well. We know how to work out the pressure because they've given us a formula for it. So it's the force divided by the area. So it's 18.9 divided by 0.45, which is, well, you can do it in your calculator, but it's 42. And then your unit is going to be newtons per meter squared or pascals. But that doesn't really matter too much for the moment. You don't have to put a unit technically for now, but it's good practice too. Pressure is measured in pascals, PA, pascals. Or newtons per meter squared, because you took the newtons and you divided by the meter squared, so that's the unit that you get. Now, we've done J. We figured out what the pressure is for J. What about K? So the pressure of K, we're told, is in a ratio with the pressure for J of 7 to 8. So the pressure for K is 8/7 times the pressure for J, which was 42. That's how we use ratios. So we can take this and we can say that the pressure for K divided by the pressure for J is equal to 8 divided by 7. That's what the ratio is telling us. And then I've just taken this and multiplied it on both sides. So I've moved it to the other side. And that's how I got this equation. So we can do that in our calculator. We get 48 newtons per meter squared, or pascals. Either is fine. Then we can look at the area. So again, we're told that the area, using the same method, is going to be 5/9 times the area of J, which is 0.45. And that's going to give us 0.25 meters squared when we do that in our calculator. Finally, we need to find out the force for K. How do we work out the force for K? Well, we can use this equation. We've got the pressure, we've got the area. So you can see that to get the force on its own here, we need to multiply by the area to get rid of it on the right-hand side, which means we also need to multiply by the area on the left. So force equals area times pressure. And so that's going to be 0.25 meters squared times 48 newtons per meter squared to give us a total of 12 newtons. And that will be our final answer, 12 newtons. Anything to summarize here? Yeah, basically we just worked through it in the order of information they gave us. So they gave us some information about J, and we were only looking at 3 things: pressure, force, and area. So we were given 2 of them. We worked out the third. Then we looked at K, and we used these ratios to work out the pressure, then the area. And then we used that formula relating for area and pressure with force to work out the force. So it was all about using the information they gave us. Okay, not many more, 3 more. 27. To be rented, a bedroom must have a floor area of at least 6.51 meters squared. It's not very big. It's 2 by 3, basically. A bedroom has a rectangular floor. The floor measures 2.4 by 2.9 meters. Each correct to 2 significant figures show that the bedroom can be rented. Okay, so what we're looking at here is we're looking at error bounds. We're looking at how big is the room. We're given these 2 things to 2 significant figures, so we don't know accurately. So it's well and good just multiplying 2.4 by 2.9 and being like, well, that's about 7 meters squared, but like it doesn't actually, we don't know that for sure because we rounded, and rounding introduces errors. So we need to look at how big could it have possibly been and how small could it have possibly been to be able to round to these. And in fact, because we're looking for at least this much, we only care about the lower bound. So the smallest number that we can use that rounds to 2.4 to two significant figures is 2.35. Because if we went any smaller than 2.35, when we round, we wouldn't round up anymore, we'd round down. So instead of going to 2.4, we'd go to 2.3. So 2.35 is the lower bound for one dimension, and 2.85 is the lower bound for the other dimension, is our lower bound estimate. All right, it's just lower bound, actually. It's not an estimate. It's just the lower bound. So now that we've got that, we can multiply those to find the area. So 2.35 times 2.85 gives us an area of 6.6975 meters squared. And we do need to be exact with that. That's supposed to be meters squared, but it looks like centimeters squared. There we go. So 6.6975 meters squared. That's our area. But all we need to know is this lower bound bigger than 6.51? Well, yeah, that's bigger than 6.51 meters squared. So yes, can be rented. And that's all you need to do, because it's a show that question. So you needed to say, what is the lower bound? That's 1 mark. What is the area? That's 2 marks. A correct comparison and answer, that's your 3rd mark. Nice and simple. Okay, question 28. We only have 2 questions left. Promise we'll make it quick as we can. So, question 28. AB, BC, and CD are sides of a regular 12-sided polygon. So here we've got a 12-sided polygon. And then we're attaching that to CDMN, which is a square. So crucially, they have a shared side CD. So since these are all the same length, these will all be the same length as well, because it's a square and a regular shape. So let's remember that for later. We're asked to prove that A, B, and N lie on a straight line. So we would love it if that straight line could continue and hit N. This isn't drawn accurately, so we don't know. Well, yeah, we don't know whether they do or not yet. We need to find that out. We need to prove that they do. So let's say if we could work out the interior angle here and prove that the angle here together, they summed to 180, then we'd be great because we'd know that we'd have a straight line. So we're aim to prove angle ABN is 180 degrees. That's what we're aiming for going into this. Then we'll know that it's a straight line and we'll be happy. How can we do that? Well, let's first talk about interior or exterior angles on a regular polygon. So an exterior angle is where you take a regular well, it's where you take an angle, you take a side, and you extend the side. So you make that into a straight line, and it's the angle on the outside, on the exterior of the shape. That's your exterior angle. And this is hopefully something you'll know or will remember for your exams, but exterior angles of a regular n-sided polygon are 360 divided by n. So you take 360, total angle in a circle, total angle in a quadrilateral, you divide it by n, and that's the exterior angle. So on a regular quadrilateral, as an example, a square, that's the only regular quadrilateral, you take 360, you divide it by 4. So if we extend one of these sides, you see that this has to be 90 degrees because 360 over 4 is 90. That's how you use it. Or on a triangle, for example, 360 over 3 is 120. So this is 120 degrees, which is accurate because the interior angle is 60 and that adds to 180. So that's how we do the exterior angles. What about the interior angles? So you don't need to learn both of these. It's helpful too. You might as well. They're not that hard to remember. One of them is enough to work out the other one because the interior angle and the exterior angle add to 180 degrees. So if you learn this one as well, it's just a different way of doing it. So I'm going to do my best to draw a fairly regular pentagon. And I'm going to choose the top point here, and I'm going to split from there into triangles. So I've drawn lines from that point to every other point on the regular polygon, on the regular pentagon. And it means I've split it into 3 triangles. And in general, with any n-sided shape, when you do this, you'll split it into n-2 triangles. Now, each triangle has 180 degrees in it. That's a rule that we learn about triangles. So there's 180 degrees. Those are not super well drawn. There's 180 degrees. There's another 180 degrees. And there's a third set of 180 degrees. So the total interior angles of a pentagon is 3 times 180. And the general rule for this is that the total, I'm going to write total sum of interior angles of a regular n-sided polygon. The total sum is n-2 times 180. So n being the number of sides, take 2 off because that's the number of triangles you make. Drop my pen. Take 2 off because that's the number of triangles you make. And then multiply it by 180 because there's 180 degrees in every triangle. Now, if you want to find each individual interior angle, you just divide it by n at the end, and that tells you what you need. So specifically in this case, we're looking at a 12-sided polygon. For a 12-sided polygon, interior angles are 12 minus 2 times 180 divided by 12, which is 150 when you put that in your calculator. So you get 150. Each of the interior angles is 150. So let's mark that on our diagram here. That's 150 degrees. Put my little degrees symbol there. 150 degrees. So this is what we're trying to prove. Let's remember that. If we can prove that this angle, angle CBN, is 30 degrees, we'll be golden, because then we'll be happy. Then we'll have proved what we wanted to prove. So that's the next thing we're trying to do. So let's look at this triangle CBN in a bit more detail. We know from the first thing we said when we looked at this shape that it's an isosceles triangle because CB, it's a regular shape. So CB is the same as DC, but then DC is on a square. So DC is the same as CN. So CB and CN are the same. We have an isosceles triangle then. So we know that this angle CBN is going to be the same as this angle CNB. And finally then, to work out what CBN is, we can work out what this angle is, and then use our triangle rule. So what's this angle at C, the angle BCN? Well, we know angles around a point add to 360. So if I have 3 lines meeting at a point, the total angles around that point will make 360 because it's a circle. And so we know the interior angle here is 150 because it's a regular shape, so they're all 150. We know the interior angle here is 90 because it's a square. So we know then that angle BCN is 360 minus 90 minus 150. And that will give us 120. So this is 120 degrees. We'll mark that on. And we know then that the other two angles are the same as each other. And when you add them to 120, you get 180. So angle CBN then is 180 minus 120 divided by 2, which gives us 60 over 2, or 30 degrees. Now, success. I said if we get that this is 30, we're done. We've proved it. But we do need to actually write it. We haven't technically written everything we need to write yet. So let's write what we need to write. Two ways to write the statement that we want. First way, we could say the exterior angle of a 12-sided shape is 360 over 12, which is 30. And therefore, because this is an exterior angle, it must leave on a straight line. That's one way to do it. The other way to do it is what we said before. Angle ABN is 150 plus 30, and 150 plus 30 is 180. So it's a straight line. And that's the way we're going to write it here. So angle ABN equals angle ABC plus angle CBN, which equals 150. That's not a very clean 150. 150 plus 30, which equals 180 degrees, which means straight line. And now we're done. Because we've proved that the angle from A to B to N is a straight line. Wow, a lot to do in that question for 4 marks. But what did we actually do? Let's have a little summary. We figured out what we wanted to prove. We wanted to prove that this angle ABN was 180 degrees, was a straight line, which means we needed to look at the interior angles, and we needed to look at the angles around the point C. And once we'd worked out those, then actually using the isosceles triangle to get CBN on its own wasn't too difficult. And we managed to do the last point. So we were all finished. If you're wondering where the 4 marks come from, you'd get a mark for 150. You would get a mark for 120, a mark for 30, and a mark for doing the sum to show that it's the final line. Those are where the 4 marks go. It's been a long time coming, but we're now on the final question. At the end of this, it says end of questions, and we can rejoice knowing that we've done a really good, solid day's work on this paper. So, question 29. The equation of a curve is this. Y equals x squared minus 18x plus 70. So firstly, let's just note that's a quadratic. It's going to be a quadratic curve. We've got a positive shape, shaped curve because there's no negative in front of the x squared. So it's going to be U-shaped rather than N-shaped. N for negative, U for smiley face. It's a positive curve. I guess the N could be a sad face too. So we have this shape. And then it's just a question of where is it going to be on our axes? Is it going to be like that or what? So we're going to look for the turning point. How do we work out the turning point? It says completing the square, work out the coordinates of the turning point. What does completing the square mean? Completing the square means, just write it out again here quickly. It means writing x something squared plus something. Or minus something, you know? What do? Well, we take this thing in front of the x and we cut it in half, so minus 9. And we write x minus 9 squared. Then we look at what this would be squared, which would be 81. And we have to take that away. But then don't forget that this plus 70 is still sat there. So then you get x minus 9 squared minus 11. Why is it that we do this step? Where does completing the square come from? Okay, well, if we were to expand the brackets of if we were to expand the brackets of x minus 9 squared, we'd have x minus 9, and using our first outside, inside, last, we do x squared minus 9x plus 81, which is x squared minus 18x plus 81. So you can see if we're trying to make just this, then when we write this, we actually have 81 too much. So we've got to get rid of the 81 to make sure that this is actually equal to this. In other words, another way of thinking about this, we worked out that x minus 9 squared was equal to x squared minus 18x plus 81. If I take this to the other side, so if I subtract 81 from both sides, then you can see that if I want to replace this with something squared, I can just copy that directly. And that's what we did. So we ended up with 8 minus 9 squared minus 11. That's all that's important. We've completed the square and we've got this. We've got x minus something squared plus something else. How does this give us the turning point? Well, the turning point, given that we know it's this shape, this U shape, the turning point is the minimum point. It's the lowest point that we get to. Now, this x minus 9 squared is a square number, or, it's something squared. Squares are always positive. If I take a positive number and I square it, I'll get a positive number. If I take a negative number and I square it, I'll get a positive number. So it's always positive, except for 0, because 0 squared is always 0. So the smallest that this x minus 9 squared can be is 0. So the smallest that the whole expression can be is 0 minus 11. So the minimum is minus 11. And it happens, well, y equals minus 11. And it happens at this bracket being equal to 0. Well, that happens when x is 9, because 9 minus 9 is 0. So we know then that our minimum point has a height of minus 11, and it happens when x is 9. And that's our answer. And we are done with this paper. Congratulations on making it to the end. It was a long paper. There was a lot to do. But yeah, very well done. I'm going to stop sharing my screen now. And then you should hopefully see me full screen now. And I just want to say that I really hope that you found this video helpful. I hope that if you did, you will like, comment, subscribe, share the video with people who will find it helpful. That's the only reason we're doing this. We're doing it to sort of help students learn how to do GCSE Maths. And I hope that my explanations helped you learn. I teach on spires.com. So if you're looking for a one-to-one tutor, that's what I do. You can go to spires.com and look for a tutor on the website there. There's loads of professional tutors that are great. You can get in touch with them. So please do. That's all from me. Have the best time. See ya.